Hi guys, welcome back to SuperMath4U. This is Mr. Urrego, and today we're recording the Algebra 1 EOC review, the best standards. This is from the district. A couple things from here. I went through all this information, okay, and I think the reference sheet deserves a full video. This is the information that you'll have available during the test, so you need to know how to use every single one of these formulas. One more thing, sample test for grade 3 to 10, okay. I went through this, guys, and this is what happened. This is a link to practice test, and this is the information that we have from last year, which is weird, but I guess that's what it is. We're doing the Algebra 1, okay. Select, begin test now, and as soon as you see this, all right, let's go back to the video from last year. And the video from last year that I had was Algebra 1 2023, okay. Let me go to question 1, and dog has 8 square pieces. All right, so I'm going to put a link. That's kind of what I'm saying right now, is I'm going to put a link to that video so you can review it. This is very valuable information, and this is recommended, all right, in their guide. Let me go back. Now I'm here, so I went through all this material from them, all right. Algebra 1 reference sheet, and this is the test that I did last year, so please go over that. Click on the top right, and that will be the link for that video. All the videos that I have, guys, from the B.E.S.T and the EOC from before, they're relevant, okay. Those are amazing reviews. You have time to review. You have a month or so. Please make sure you practice every single day, at least half an hour. Having said that, the new information that I have here is this mixed review. Okay, so this is the copy that we're going to work on. All right, now something new about this material is that the whole thing is divided into 3 quarters. All right, so I'm going to start working on quarter 1, and then we go from here. Okay, let's get ready. Let's start. Question 1. A graph of a function is shown on the coordinate grid. The function on the coordinate grid is, and the options are cubic, linear, quadratic, exponential decay, exponential growth. All right, because we see, guys, that my line is increasing. All right, linear, straight line, quadratic is going to be parabola, cubic is going to be something like this. All right, but this one has an asymptote on the x-axis, as you can see, and is increasing as we go. So this is exponential growth. All right, exponential decay will be something like this. Keep that in mind. Part B, which of the following is the parent function? Because this is an exponential growth. Exponential growth, that means that my variable is going to be on the exponent, right? You can see that the variable is the exponent, so this is an exponential function. The first one is a quadratic. The second one, this is just a number, that's a constant. This one is a cubic, and this one is a linear. So my answer is D. So again, exponential growth, and this is the parent function. Question number 2. S of D, the function S of D equals square root of 9.8 D estimates the speed S in meters per second of a tsunami based on the ocean depth D in meters. Determine the speed in meters per second of a tsunami at a depth of 2,145 meters. Round your answer to the nearest 1,000. So, guys, the only thing that we have to do here is just plug it in. That's all we need to do. So I'm going to do 9.8 times 2,145 equals, and then I have to do the square root of that. Okay, 144,986.2. So that means it's going to be 144,986.2, right? They're asking me for the nearest 1,000. So the first decimal is 10th, 100th, 1,000. So I need to round to 3 decimal places. I look at the next one, and because this is lower than 5, then my 6 stays the same. So this is my answer. Question 3. Microplastics are buoyant plastic materials greater than 0.5 centimeters in diameter. Researchers determined that if the emissions of microplastics were stopped in 2002, 2020. The amount of plastic in oceans could be estimated using the function P of x equals to that. Okay, great. Where x is the number of years since 2015, and P is the amount of microplastics in hundreds of tons. So that's the weight in the ocean, which is the correct interpretation of P of 27. So a couple of things here, guys. You see that my function is P of x. If they give me P of 27, that means the value inside the parentheses, this is the x value. All right. Now, when does we start? In 2015. So what you need to do is to get 2015 and then 27 years more. That's going to give me 12, 4. So the year is going to be 2042. If we go straight to the answers without looking at anything else, there's only one answer with 2042. Normally they're going to give you a few answers with the same value. Keep that in mind. Now let's understand what the 7332 is. That's 7,332 what? That's hundreds of tons. So if I want to turn this into just regular tons, not hundreds of tons, what I'm going to do is I'm going to bring the number and multiply by 100. When I multiply by 100, the only thing that I need to do is just add 1, 2 zeros. And then my number is 733,200 tons, which is the right answer. So my answer for that is C. Let's go to number 4. 6 expressions are shown, right, from A to F. The question is, select all the expressions that are equivalent to 36 to the negative 2/5. A couple things, all right. One is, when I have a negative exponent, like I do here, right, if I want to turn it positive, the only thing that I need to do, guys, is just flip it. Move it to the bottom, all right. We're going to start with that. And then if there's nothing on the top, you just put a 1 on the top. That's the first thing. The second thing that I want to address is real quick is when I have a rational exponent. You see my exponent is a fraction. When that happens, the reason for that is because I can rewrite 36 to the 2/5. This 5, all right? There's a reason I'm doing this. This is the same as a radical, right? 36 on the inside, square on the inside, but that thing that I put on that the denominator of the fraction of the exponent, that is my index, all right, which is a tiny number that is inside the radical. If I have a radical and there's no index on the outside, on the inside, then you have a tiny 2. That's why we call it square root of this. But again, if there's nothing there, I know that it's a 2. I don't have to write it. So square root of 9 is 3. I'm sorry that I got out of on a tangent, but just to explain the index. So when I have a fraction as my exponent, what's happening is I have a radical. That belongs to a radical. Let's keep going. So as we can see, this is this. So if I want to write this as a radical, it's going to be 5th root of 36 to the 2nd power. Okay? Right there, I can look at F. And as you can see, they put the 5 as the exponent. No, that's the 5 is not the exponent. 2 is the exponent. 5 is the index. So that's the wrong answer. All right. Let's keep going. Let's go to A. All right. A, what's the exponent for A? It's the 5. It's negative 5. It's supposed to be a 2. That's the wrong answer. All right. Now let's look at B. B. So you have 36 to a negative 2. Everything to the 1/5. What happened with this is the following. When you have two exponents, which I have here, square and 1/5, when you have two exponents, what you do is you multiply them. So I'm multiplying negative 2 times 1/5. If you remember how to multiply fractions, 1/5 is a fraction. I gotta turn negative 2 into a fraction. I put over 1. And then I do the top with the top, which is going to give me negative 2, and the bottom with the bottom, which is 5. So having 36 to the negative square to the 1/5 is the same as negative 6 to the negative 2/5, which is what I have here. So this is a valid answer. Right? Now we're looking at C. Now, one thing that I can say is that when we have a square, guys, you see this square that you have on the inside? You can have it on the outside. So I can say that this 1 over 5th root of 36, instead of having it on the inside, I can have it on the outside. And I can even extend that because the number on the top is 1. And if I do 1 to the second power, it's still 1. So I can extend this big parenthesis and say, oh, all right, hold on. This is the same as 5th root of 36, everything to the second power. So this is a valid answer. Let's go next. Now I have 36 to the negative 1/5. 36 to the negative 1/5, I'm sorry, right there. Everything to the second power. Same thing that I did here, I'm going to multiply, in this case, 1/5. Let's change the sign right there, negative 1/5 times 2. And let's change this times 2. Positive times negative is going to give me negative. I'll still get negative 2/5. So this is another answer. So far we have B, C, and D. Let's check for F. All right. So what happens with F is the following. You have 36. You have 36 to the negative 1/5 plus 36 to the negative 1/5. Okay. If I rewrite this as radicals, I have 36. All right. Plus another 36 to the negative 1. So you have that. When you have radicals, guys, you have one of this plus another of this. That means I'm going to have 2 outside the radical, 36 to the negative first. So when adding radicals, this 2 doesn't go to my exponent. I cannot add the exponents of this because I'm adding. So I believe that, let's pretend that this is an apple and this is another apple. I'm adding 2, so I have 2 apples. I'm not able to add the exponents. Keep that in mind. When I'm adding radicals or rational exponents, I'm not able to add the exponents. The only time that I add the exponent is when I multiply. If I do 2 to the 3rd power times 2 to the 5th power, then this is when I add the exponent. This is going to be equal to 2, and 3 plus 5 is to the 8th power. All right, so here's a mistake because they're thinking that I'm going to add the exponents, which is negative 1/5 plus 1/5. That's going to give me negative 2/5. That's wrong. So my answers are B, C, and D. Number 5. An expression is shown. Which expression is equivalent to the given expression? A couple things, guys, is the following. Look at this. They ask you for which expression, so it's only one answer. All right, and when they give you boxes like this, then they can ask you for many choices. All right, so it's actually easier because you're looking for just one answer. Here, we have a number on the outside and then we have a parenthesis. So what we need to do is distribute those answers on the inside. When we're doing radicals, the first radical that you have is 5 square root of 6, right? Times 7 square root of 3. When you're multiplying two expressions, two radical expressions, you're going to multiply the numbers on the outside with the numbers on the outside, and then the inside with the inside. So it's 5 times 5 is going to give you 35 square root of 6 times 3, which is 18. All right, and now I'm going to go for this one. If there's nothing outside the 12, you have a 1. So it's 5 times 1, which is negative 5, and then the 6 times the 12, which is going to give you 72. So that's my answer. Do you have anything like that? Not really. Okay, because you have you see this 5, there's no, you have 18 here, but there's no 5 here. Okay, so please do not get confused with this. Now what's going to happen is the following. Every time we're doing radicals, I need to simplify what is on the inside. That means I got to take the 18 and break it. 18 is made out of 9 times 2. 9 is 3 times 3. Okay, when I have radicals, my index is 2 square root. There's nothing there, you have a tiny 2. The way I explain to my students is the following. 35 is on the outside. I want to get whatever I can out of the radical, the 18. The 18, I see that I have 2 3's. My index is 2. So for every 2 of the same number that is in the inside, remember this 18 is on the inside, so technically all those numbers are in the inside of the radical. For every 2, 1 comes out. I had 2 3s, 1 3 came out. There's only 1 2 left. My index is a 2, so it tells me that I need 2 of the same because I only have 1 2. That 2 stays on the inside. Minus 5, and I gotta do the same thing with the 72. Same thing, same process that I did with the 18, I gotta do with the 72. So 72, again, is inside the radical. I gotta break the 72. 36 times 2. 36 is 6 times 6. Hold on, my index is a 2, which tells me that for every 2, 1 comes out. There's only 1 2 stays inside. All right, guys, radicals. I suggest for you to go to my channel and search for radicals. I have a full several videos about radicals. It's very important for you to know how to simplify radicals expressions. Okay, now any number that comes out, it will multiply the outside. So this 3 came out, multiply the 35. 35 times 3 is going to give you 105 if I'm not mistaken. I keep the same radical. Minus 5 times 6 is going to give you 30 square root of 2. These radicals are like terms because they have the same radical, the same radicand, which is the number on the inside. So what I need to do is I'm going to say, oh, I have 105 of this minus 30 of the same. 105 minus 30 is going to give you 75, and I keep the same radical, which is square root of 2. Alright, so if you notice, in the beginning we thought this was the answer, but it's not. 75 square root of 2 is A. So they want you to work around the radicals and simplify them. Again, go to my channel, check radicals. I have full videos about this, explaining in little detail. Let's go to the next one, number 6. An expression is shown, and I have all that. Select all the expressions that are equivalent to the given expression. Okay, so it's going to be more than one. Let's do one at a time. The first thing that you want to do, guys, is the following. I want to know how much is that on the top. So the first thing you have to do is simplify this. So everything, whatever's on the outside, is going to distribute to the inside. So negative 3/5 times of x times 11. Remember, how do I multiply fractions? I make the other one a fraction, which is over 1. Alright, a negative times a positive is going to give you a negative. So 3 times 11 is going to give me 33. And 5 times 1 is going to give me 5. X times x is going to give me x squared. Now, next one. Negative times positive is going to give you negative. And again, I got to make that for a fraction, which is over 1. 3 times 4 is 12. Oops, this is a horrible 12. Divided by 5 times 1 is 5. And again, there's only one x. I keep the x. So that's my first parenthesis. I got to do the same thing with the second parenthesis. Positive 1, make this a fraction, make this a fraction, make this a fraction. All of them has to be fractions. Top with top, 1 times 45 is 45. That's going to give me positive 45 over 10. 10 times 1 is 10. Plus 1 times 4x is 4x divided by 10 from the bottom. And the last one is going to give me 1. I'm sorry, that was that. And this one is going to give me 1 times 16x squared is going to give you 16x squared divided by 10. Alright, a couple of things. As you notice, I have decimals in some of my answers. Not too many though. Alright, so one thing that you want to do is probably get this as decimals. I think that will be the easiest way. So let's start from the beginning. 33 divided by 5, that's going to give me negative 6.6 x squared. Minus 12 divided by 5, that's going to give me what, 2.4? 2.4 of x. Plus 45 divided by 10, that's going to give me 4.5. 4 divided by 10 is going to give me plus 0.4 of x. 16 divided by 10 is going to give me 1.6 x squared. Alright, once you have that, what you're going to do is combine like terms. The x squared with the x squared, so negative 6.6 plus 1.6 is going to give you negative 5 x squared. Negative 0.4 plus 0.4 is going to give me negative 2x. And the last thing is, there's only one, plus 4.5. Oops, let me change the color because the idea that I'm doing right now is color coding. So plus 4.5, which is this. All right. So the first one is an answer. Excellent. The next one is 1.6. No, I have negative 5. Right there is wrong. 47 over 5. This is 9 point something. I have negative 5. It's wrong. Okay, keep in mind, I did this process right. Make sure you do it not slowly, but make sure that you're doing it right. Okay? Be careful. Most likely they're going to give you a calculator. Alright, so we cross out these ones. We have an answer so far. Let's keep going. This one, they ask us to solve, right? So that means I have to distribute that 1/2 to every single value. Let's do that. Okay, let's see what we get. Let's do that with red, I guess. Half of 9 gives you 4.5. So far, so good. Half of negative 4 is negative 2x. So far, so good. Half of negative 10 is negative 5x squared. Even though it's not the same order, these are the same values, so this is an answer as well. All right, let's keep going. This times this, 16 divided by 10 is 1.6. No, my answer is negative 5. Right there is wrong. If you want to double check, keep multiplying, right? Keep multiplying by as you do the first one right there, you know that is a wrong answer. Next one, I have 16x squared minus 33 over 5. This 33 over 5 is going to give me what? 6.6, right? Negative 6.6 x squared plus 16 is going to be 9.4, but my x squared value is negative 5. That's wrong. All right, so I don't have to do the whole thing. As long as I have one of the answers that is wrong, the whole thing is going to be wrong. Okay, and that's number 6. Let's go to number 7. Now for number 7, I have, they're saying an expression is shown. I have 2 parentheses, 2 factors. Which expression is equivalent? Guys, always check the answers. See what they want you to answer, right? Check them. That's going to give you a heads up, or at least an idea what was being expected. Now here, be careful. When you have 2 parentheses, you gotta multiply everything. This is the famous FOIL pattern, all right? Which is the first times the first. That's gonna give me 12x to the second. Then the 4x times the negative 4, and that's called the outer. 4x times negative 4 is gonna give me negative 16x. Then I do the same process with the 7. 7 times 3x, and that's the inner. That's going to give me 21x. And 7 times negative 4 is called the last, which is going to give me negative 28. Normally, I'm able to combine like terms. So I had the first one, 12x squared, and then I have negative 16 plus 21, which is the same as 21 minus 16. That's 5x minus 28. And now let's check which one of this. And my answer is C. All right. The first 2 normally is because you guys have a lot of mistakes. You only multiply the first times the first, and that's going to give you 12x squared. And some people add 7 minus 4, which is going to give you 3. That's one mistake. That's a possible answer if you make mistakes. If you multiply 7 times negative 4, it's going to give you negative 28. That's another possible mistake that some people do. So please be aware of those mistakes. All right. Let's go to number 8. An expression is shown where h is different of 0 and k is different of 0. I'm going to explain why they're telling you that. Okay, they give you an expression Select all the expressions that are equivalent to the given expression. Again, the mixed review that we're doing, guys, this belongs to the first quarter that you've done already in the beginning of the school year. So it's very important for you to review it. Okay? Now, first of all, let's turn this negative exponent into a positive. All right? So I'm going to rewrite the first thing, which is h to the 4, k29, r3, divided by k7, parentheses 2 on the outside, times this. If I don't make that negative exponent positive, the only thing I have to do is move it to the bottom. Common mistake. The only one that has a negative exponent is the h, not the r. The r has no exponent. That means stay the same. And if there's no exponent, you should have a 1 right there. So keep that in mind. So that's the first thing they want you to do. Let's go to the answers. See which one is similar to that one. You see that? All right. H is positive. The parenthesis is the same thing, and that's on the top. So that's my first answer. Great. One answer. Let's go. All right. So let's kind of solve this one, guys. So let's finish solving our problem here in the top. So when I have an exponent, when I have two exponents, and we just did that a little bit ago, what I do is I multiply those exponents. Okay, so I'll have, let's write it here underneath. So I have h, k, r, right? And that's going to give me 7 times 2, which is 14. R, h11. When I'm multiplying, okay, I multiply the same variables. So h, this is the only one on the top, so it stays h to the 4th power. The k is the only k on the top, so it's k29. But now I have an r times an r. If there's no exponent here, you have a 1. So r to the 3rd times r to the 1st is going to give you r to the 4th power because we add the exponents. The bottom, I'm going to multiply k14 times h11. They have different variables, so I just put them together next to each other. All right, let's go to the answers and see which one looks similar to that. None of them. All right. Why? Because we still have k on the top and k on the bottom. H on the top, h on the bottom. So that means we can divide. So we have to divide. All right. So I'm going to divide h with h. All right. So when I divide, what I do is I subtract the exponents. 4 minus 11 is going to give me -7. K to the 29 divided by k to the 14 is k. 29 minus 14 is k to the 15. And then the r, that's the only one r that we have, stays the same, right? If you notice, when I divide, all my answers are on the top. I didn't put anything on the bottom. Right there, I go back to my answers, and I see that I have an h here, but the k is different, and the r is different, so this is a wrong answer. All right? Let me go back. In the second answer, I see that I have an r to the 3rd power, and my answers are to the 4th power, and my k is to the 15. Wrong answer. We know that the 3rd one is right. Okay? The 4th one we need to answer, we need to solve it, and the 5th we need to solve it. Okay, so right now I have a possible answer, which is this. Or if I have a negative exponent, guys, don't forget, if I have a negative exponent, to make it positive, I move it to the bottom. So let me rewrite the ones that have positive exponent, which is the k and the r. And this negative exponent is going to go to the bottom. So this is a final answer for my problem. All right. Now what's going to happen is I'm going to solve this one and I'm going to solve that one and see if I get the same answer. All right. So that's our idea. Let's get to it. Let's solve this one. So again, let's multiply. So if I have h to the 4 times h to the -11, that's going to give me, when I'm multiplying, guys, make this a fraction, right? h to the 4 times h of negative 11 is h. 4 minus 11 is negative 7. K, there's only one k on the top. R, there's only one r on the top. The bottom, there's only one k on the bottom. All right. Now I had to finish. I had to divide. Okay. So this h is h, which is a negative exponent, goes to the bottom. Let's divide the k29 over k49. If I'm dividing, I subtract the exponents. 29 minus 49 gives me negative 20. And the r to the 4th power. All right. Now, is that what I have? My answer is k to the 15. Right now I'm getting k to the negative 20. That's wrong. So this answer is wrong. All right. Let's do the last one. Now I need to find out how much is all days. So remember, all days are on the top. And when I multiply those, let me put a line right here because it's getting messy. All right. So I multiply the same variables, I add the exponents if they have the same sign. So let's start with the h to the 4th, h of negative 11. I add, right, exponents, but if they have different sign, what you do is subtract. 4 minus 11 is going to give you negative 7. K, there's only one k. Oh, hold on. I have this k and this k. 29 minus 14 is 15. And then there's only one r, which is r to the 4th power. All right, that's my answer from that one. Let's flip whatever it has to be flipped. Remember, this is over 1. So my answer is, I flip the one that has a negative exponent to the bottom. And the k is positive, stays the same, and the r positive exponent stays the same. Is that what I have? Yes. So out of all those answers, those two are my answers. Okay, a little messy because we have to do a lot of process. All right, let's go to number 9. A linear equation is shown. Okay, by the way, this form of my linear equation is called Poinslow form. Which equation is equivalent to the given equation? Guys, a lot of which one is equivalent? At least this one is which equation. So the answer is only one. All right, so it's much easier. Let's work. A little bit of strategy. Every time you're taking a test, guys, you do the ones that you think are the easiest ones. All right. You get stuck in one question and it's hard. Move on. Don't stay. All right. Move on, because you need good self-esteem. So you do the ones that are easy for you, so you feel good about yourself. Keep that in mind. Now, as you can see, my original problem here has parentheses, but none of my answers have parentheses. Therefore, I got to get rid of the parentheses. All right. So I'm going to keep the y plus 9 equals, and then I'm going to distribute this 5 over 2. So 5 over 2 times x is 5 over 2x. And then I make the 4 a fraction. 5 times 4 is 20 divided by 2. All right. Anything that looks like that? Not yet. Let's keep going. So right now I'm going to simplify things. So I'm going to have y plus 9 equals 5 over 2x plus 10 divided by 2 is 10. Any of the answers like that? No. Let's keep doing it. Let's leave the y by itself because I see that two possible answers have the y by itself. So minus 9 and minus 9. So I'm going to have these 9's cancel out, and you have y equals 5 over 2x. 10 minus 9 is 1. Anything like that? Look at this beauty. All right, so you have one of the answers. You can double check the other ones if you want. All right, but there's no need because there's only which equation. All right, be careful when you read which equation. There's only one. All right, simple strategy. All right, guys, let's keep going. Number 10. If you're learning so far, please hit that like the video, guys, so it get exposed to other people. All right, they can benefit from this thing. And subscribe to the channel. I have many videos like this that's going to help you out. All right, let's go. Number 10. A golf professional measured the speed in miles per hour that a golf club hit a golf ball at, and the distance in yards the golf ball traveled. The data is shown with a dotted line that represents a line of fit. A line of fit, right? What they're saying, right, guys, is line of best fit. If you notice, all the points are not in a straight line. Now let's scroll down. They're saying a zoom version of the graph is below. All right, so they took a little piece and they zoom in. Thank you for that. So now let's concentrate on this. They give me the points. All right, if you notice, not all the points are on the line. All right, some of them are above, some of them are below. This is a scatter plot. That's what it's called, a scatter plot. Now they give me the order pairs of that scatter plot. Let's go to a question. Complete the statements. Okay, the equation of the best fit shown in the graph is best determined using the points, and this red are for the first choice, this blue are for the second choice. They're saying the line of best fit. When you're doing the line of best fit, guys, you have the line already. Okay, so you want to use points that are line on the line. Do I want to use 43, 152? No, it's not on the line. Okay, what they give you only 3 choices. So yeah, I don't want 43, 152 because it's not on the line. 45, 150. No, it's not on the line. 46, 157. Look at that thing. Yes, so this is my choice for the first one. Second one, 59, 193. I'm hoping you get the idea. It's not on the line. 64, 201. 64, 201. It's outside the line. Let me see the other one. 57, 185. 57, 185 is on the line. You see that? So my answer is 57, 185. All right? So you want points that lie on the line. And also, I don't think they're going to ask you to draw the line of best fit. Draw the line of best fit is they can give you points all over the place, guys. They can give you points all over the place. And then they ask you, draw a line of best fit. It's not going to happen. But at least you know the concept of how to do it. The idea when you're drawing a line of best fit is to have points above and below. You see, like through the middle. The line goes through the middle. All right, so now I have my points. Let me write my points over here. So it's 46, 157, and then I have my second point is 57, 185. Let's go to the next question. The equation is the following. All right, so here the last point, the equation is this, and they're going to give you 3 or 4 choices. Unfortunately, you have to find the equation. All right, if you remember before, I said this line is point slope form. Let's see if we can get to that. Yes, remember this? This is point slope form. So the first thing that you need to do here is to find the slope. So most likely the choices are going to be given in this form, which is an easy one. But this that is in front of the parentheses, that's my slope. I need to find that. So that's we need to do here. All right, I got my 2 points. Let's find the slope. Now, real quick, my slope is y2 minus y1, x2 minus x1. Once I have that, I'm going to label my points. The first value is x, the second value is y, x, and y. You choose the first point to be x1, y1, and the other one is going to be x2, y2. Replace. All right. y2 is 185 minus y1, which is 157, divided by x2, which is 57, minus x1, which is 46. All right. 185. Let's change the values, change the color here. Let's do color coding right now so we don't get confused. 185 minus 157. Hold on, that's what, 28? 28, and 57 minus 46 is 11. So my slope is 28 over 11. Now the choices that they give you here, guys, there's 3 choices. Unfortunately, I don't have the 3 of them on right now. Now, let me show you how to write this in Points law form. So the Points law form is y minus y1 equals m x minus x1. The three things that you need to replace here is your slope, which I already have, 28 over 11. The other things that I need to replace is y1 and x1. That x1, y1 can be your first point or it can be your second point. For the most part, first point is used. So if I want to write this function like this, I'll say, let's go, y minus y1, and y1 is 157, equals my slope, which is 28 over 11, x minus x1, which is 46. And this is the equation of the line. This is called Points law form. Again, if you get this, fine. If not, go into my channel. There's videos for this as well. Alright guys, moving on. Let's go next. Number 11. This one is a long one. And again, some of these word problems, guys, are simple. It's just a matter of reading them. Do not give up on the word problems. If you're getting confused or you're getting aggravated or overwhelmed, move on. Right? Flag it and come back to it. But make sure you come back to it. Make sure there's nothing blank, guys, on your problem. Alright, I'm going to read it and see how crazy it is. A foundation for outdoor activities tracks the number of participants in a variety of sports. A researcher used the data for the number of participants, in millions, who played tackle football for the years between 2007 and 2011. Alright, keep track of those values between 2007 and 21. Alright, participants are in millions. Alright, the researcher found that the equation of the line of best fit is this, where x is the number of years since 2007. X since 2007. So this is year 0. So 2007 is year 0. And y is the number of participants who play tackle football in millions. Alright, so y is the number of participants in millions. You need to understand what's x and what's y. Very important. Some of the data in the line of best fit are shown on the corner grid. You see, line of best fit, because you have points all over the place. You want to draw your line through most of the points. Some of them are going to be above, some of them are going to be below. Try to have an average, right in between. That's kind of the idea. Let's go to a question. Which statement is the correct interpretation of the data and the line of best fit? All right. Let's start reading. All right, so let's write the equation here. Y equals negative 0.25 of x plus 7.75. All right. Remember, x is, where is the x? Hold on. X is the number of years since 2007. X is the number of years since 2007. And y is the number of participants who play tackle in millions. All right, let's scroll down. For every year, 7.75 million more people play tackle football. Every year. So they're saying in year 1, let's pretend that 3 million play. In year 2, you are going to add 7.75, which is going to give you 10.75. In year 3, you're going to add 7.75 again, which is going to give you 17. So what's happening here, guys, is for every year, this is the more people play. This is your slope. That's the rate of change, right? For every year, that's rate of change. Rate of change is my slope. Is that 7.75? No. Let's understand the equation and let's understand the graph. Two things. Let's look at the graph. This is year since 2007. So right, this one is 2007. And 2, this is 2009. And right, plus 2 is 2011. And so on and so forth. The y values, these y values are the number of participants in millions. What's happening with my line, guys? It's going down, it's decreasing. So as the time goes by, the number of people is decreasing. That's why my slope is negative, right? The number of people that is playing this thing is decreasing. It's not increasing. There's 7.75 more people. That's wrong. All right, so our graph is telling me that the number of people is decreasing and my slope is telling me that it's negative, so it's decreasing as well. B, there's 7.75 million people who play tackle football during the years 2007 to 2021. There are 7.75 million people who play tackle football during all those years. They're saying that this is the total of people that plays tackle football. Is that right? No. In year one, we have almost 8 million people playing, right? 2007. And as we go, they're decreasing. But this is not a total. If the total will be adding every single point here, that will be a total. In 2007, almost 8. In 2009, almost 7. That's 15 million, and so on and so forth. It's decreasing, but overall, that's a total. They're saying in total. That's wrong. For every year since 2007, there are negative 0.25 million people who play tackle football per year. That's right. That is right. But there's something weird about this answer. Let's look at the next answer. During 2007 to 2021, I see what's happening here. Guys, our original problem, they're saying between 2007 and 2021. Do we know what happened after 2021? Do we know what happened after in 2022 and 2023? No. This information is only all the way to 2021. So let's go back to the answers. During 2007 to 2020, the number of people who play tackle football decreases by 0.25 million per year. Saying negative 0.25 and saying decreases is the same thing. So these two answers are exactly the same. The only difference here is they're saying between 2007 and 2021, which is right. So this previous answer is right, but it's not completely right because it's missing all the way to 2021. So out of those two answers, this is the one that is most precise. Holy cow. These people are going crazy, guys. So please make sure you read carefully the answers. All right, that's kind of the idea right now. Next, number 12, we're doing great. A researcher for a music company researched the sales in tens of millions of dollars of music cassette tapes. Oh my God, guys, this is from the 80s. So, in tens of research the sales in tens of millions of dollars of cassette tapes. Y for X years since 1980. X is the years, Y is the sales. For the years 1980 to 2000, all right? Nothing else. The researcher used some of the data for the years 1980 to 2000 to determine the line of best fit. A graph of the scatter plot and a graph of the residuals are shown. All right, residuals. So guys, residuals, unfortunately, as it is, just for the residuals, that's a full class. So, all right, we have a couple of problems in the previous one. Don't forget, guys, to check the previous video from last year. That's a recommendation that they're doing on the Florida State Department of Education. So check the link on the top right and check that one. All right. Don't forget, study at least half an hour every single day from now until the EOC. When you get a 5, guys, trust me. A lot of people that have done all these videos from my channel, they comment 4 or 5s, amazing, right? But you got to do the work. You got to study. Let's go. Residuals. I'm not gonna go crazy with the residuals, guys, but let's read the answers first of all. So the question is, which statement best describes the information about the line of best fit that can be determined from this residual graph? So this is the line of best fit. So these are my scatter plots. Technically, there's no line of best fit. If I want to draw a line of best fit, this would be some kind of quadratic function. All right. But according, if you have a residual graph, then what they did was they didn't do a quadratic function. They did a linear function. So I need to draw a line through most of my data. All right. And the residuals, guys, is nothing else than let me show you. Let me explain real quick. Let me pretend with a straight line here. I need a straight line. I guess I don't have a straight line right now. So you need to draw a line, hopefully through 1 or 2 points, that will represent your data. That's the line of best fit. If you notice, guys, I am drawing my line mostly through the top. Why? Because that's where most of my points are located. Here, I got 1 and 2 points. This sometimes called outliers, if they're too far from the information. Again, the line of best fit that will fit this data is a quadratic. When you have residuals, it's a linear function. So I'm drawing a straight line through most of my points. You see, all these points are close to my line. These are 4, but there's only 2. I got most of my points right next to my line. The question is, let's draw again. All right, let's pretend let's pretend, right? Let's go and read the answers. The line of best fit will have a weak fit because the residual values have a pattern. The line of best fit will have a negative slope because the residual value rise and then fall. Negative slope. This line doesn't have a negative slope. This line has a positive slope. That's wrong. The line of best fit will have a positive slope because both the scatter plot and the residual values match. Not really. That's not the answer. The line of best fit will have a strong fit because both. Hold on. Let me see what's going on here. Positive because both the scatter plot and the residual values match. Not really, even though, guys, I've seen multiple of this type of graphs, and when this happens, unfortunately, when this happens, this is right. I will emphasize the positive slope. All right, I will emphasize the positive slope. So this could be an answer. Let's read the D. The line of best fit will have a strong fit because both the scatter plot and the residual values rise and then fall. Strong here, what is that? Strong fit. And weak fit is how far are the points from the line of best fit. All right, how far are the points from the line of best fit? Strong correlation or weak correlation. In this case, it's a weak correlation. But out of this possible answer, guys, this will be the stronger out of all of them. And again, don't go crazy with residuals because there's much more to it. Much more to it. All right. Let's go to the next one. 13. The graph of a line is shown. All right. Much easier problem. Every time you're doing a test, you go for the easy ones first, which in this case is this. Let's see what the question. What is the equation of the line in standard form? All right. So we already went through the Points law form, which was the previous one. The standard form, guys, is 8x plus by equals to c. All right, this is a b. So in general, the idea is to have your x and your y on the same side of the equal sign. All right, you see the equal sign? So you want your x and your y on the same side. One more thing. A requirement is if it's standard form, all the numbers have to be integers, whole numbers. You see that there's no fractions or decimals here? They have to be integers, whole numbers. One more thing is the value in front of the x, this a value has to be positive. All right? So if you see an x value that is negative, right there, that's wrong. You see this negative? That's wrong. The a value has to be positive. So those are choices right there that we can just cross out. All right. Now let's go back to it. The first thing you have to do is find the slope. But now we have the drawing, right? We have the line. So to find the slope, what we're going to do is we're going to use rise over run. All right, so we have several points. I'm going to take 1 point and another point, and I'm going to go vertical. Let's do this. I'm going to go vertical, and then horizontal. All right, and see how much is each one of them. All right, so I went down 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. So because I'm going down, and y is negative, and then I'm going to the right, and I'm going from -7 to 0. So that's 7 steps, because I'm going to the right is positive. So my right is the y value, so it's -5, and the run is the x value, which is 7. So my slope is -5/7. To write my equation, I'm going to use y equals mx plus b, right? And then I turn that into my standard form. I had to start either here in my slope-intercept form or my point-slope form, either one of them. The reason I'm using the slope-intercept form is because I have the y-intercept. Look, the y-intercept is where your line touches the y-axis. So my y-intercept is equal to 4. So I have this value. All right, so my slope is -5/7x plus 4. If I didn't have the y-intercept, I would use the point-slope form, which would be easier. Once I have that, guys, I need, again, can I have fractions? No. To get rid of fraction, guys, the idea is to get rid of the denominator. I don't need the denominator. To get rid of something that is dividing, what you do is you multiply. All right, you gotta multiply everything. That's why I put parentheses. 7 times y gives me 7. Why did I put x? What's going on with me, guys? Come on. 7y. Then 7 times this. Remember, you have a 1 underneath, right? So 7 times -5 gives you -35x. And the bottom is 1 times 7, which is 7. Next, 7 times 4 is 28. All right, once I do that, remember the idea was to get rid of this denominator. So let's simplify. So I have 7y equals -35 divided by 7 gives me -5x plus 28. Last, I need the x and the y on the same side. So I don't need the x on this side, I'll need it on the other side. So my last step is 5x plus 7y, this cancels, equals to 28. Therefore my answer is A. And at this point, guys, we already practiced slope-intercept form, standard form, and the point slope that we did already. Okay, we're almost done with the first part of this review. Again, this is quarter 1. We had 3 quarters in total. Let's keep going. Question number 14. If you're tired, stop. All right, come back the following day. Put time to review for the EOC into your routine. That's what I meant. There we go. Let's go. 14. The percentage of U.S. households with access to cell phone in 2004 was 63%. Percentage of households in 2015 was 92%. Much more people, right? All right, cell phones. What equation models the percentage of households with access to cell phones for years since 2000? Since 2000. All right, let's go. So guys, something that you have to be aware is when they say since 2000, right? That's X years. That means in 2000, my X equals 0. All right, so be aware of that. That's a little clue right there, but you have to be careful with that. So let's write this. 2004 was 63%. Okay? So, but 2004 is not 2004. 2000 is 0, then 2004 is 4. Okay? So that's my x value. So 63% is the y value, and that's my first point. Let's go 2015. If 2000 is 0, 2015 is 15, and is 92%. All right. As you can see, they're using the 92 and the 63 because we see the 63 all over the place. So they're using the percentages. What I need to do is find at least the slope. If I find the slope, guys, I can tell which one is going to be 11 over 29 or 29 over 11. All right. We got to label them. Again, I'm hoping that you see that we're repeating some processes already, right? We're repeating processes. So this is x1, y1, and the other one is going to be x2, y2. And I need to find my slope. y2 minus y1 over x2 minus x1. All right, y2 is 92 minus y1, which is 63. x2 is 15, and x1 is 4. 92 minus 63, I believe, is 29, and 15 minus 4 is 11. So now I know my slope is 29 over 11, which is not this and is not that. Now I'm going to use one of those points. Guys, if you can see, they're using 63 and 4, so I'm going to use my first point like we did in the other one. So y minus y1 equals mx minus x1. Remember, we need to change the y1, the slope, and the x1. All right, so y minus y1 is 63 equals my slope, which is 29 over 11 in parentheses x minus x1, which is 4. Therefore, my answer is yes, D. That's right. Excellent. All right, we keep practicing the same thing. All right, next one. I believe that's our last one. Let me see. Yeah, last one. Okay. I think this video is getting too long right now. 53 minutes. Yes, it's getting too long right now, so I think I'm going to stop this one and do a different video for the marking period 2. All right, and then a different for marking period 3. Please, those are great reviews, guys. You need them. All right, so make sure you review this. Again, subscribe to the channel so you get the notification when I upload the second one and the third one. Don't forget, click on the top right corner because you can go back to the previous year. That's a review. And not only that one, I already have 2 more or 3 more very good reviews about this, guys. So far, people, I have so many comments saying that they pass, but you have to study and you have time for this. All right, let's go. 15. The U.S. Census conducted a sample survey of consumer purchase of 80,000 households to determine the sales of various sporting goods. The sales of tennis shoes in tens of millions of dollars for the years since 2000. And here we go again. For the years since 2000, so that's year 0, can be modeled by a linear equation. A table of values for the linear equation is shown. All right, so the topics that we'll be doing are linear, no quadratic, no cubic, no exponential, only the first one. Let's go straight to the question and see what's happening. Which equation models the relationship? All of these are in slope intercept form. We need to find the slope. As we can see, we got 2 choices, 0.23 and 0.46. All right, so we need to find the slope. As soon as we find the slope, we're going to at least be able to cancel one of those 2 possible answers. To find that, you can use any 2 points, guys. Any 2 points. In my case, let me say that I'm going to use the first point, and I'm going to call this is x1, and therefore this is y1. And let me use on the 9, x2, y2. All right, that's the first thing you have to find, right, guys? Because this is y equals mx plus b. Slope. My formula is y2 minus y1 over x2 minus x1. My slope, y2, which is 3.47 minus y1, which is 5.08. In decimals, we need calculator. x2 minus x1, which is 9 minus 2. Slope equals 347 minus 508. Here is negative 1.61. Beautiful. Remember, you have a calculator from the EOC. So negative 1.61. 9 divided by 2, 9 minus 2 is 7. And this divided by that, negative 1.61 divided by 7. Negative 0.23. So my slope is negative 0.23, therefore can cross this out. Okay? Now, if you notice, I have two different y-intercepts. None of these are y-intercepts. In order for those to be y-intercepts, my x value will have to be 0. If you have a 0 as the x, then this will be your y-intercept. Because that's not happening, that's not the case. None of them are y-intercepts. So what you need to do is find the y-intercept. To find the y-intercept, you write your equation again, mx plus b. You're looking for the y-intercept, right? This is what you're looking for. So you need to replace the y, the m, and the x. How do you do that? You got the slope already. What about the y and the x? What you're going to do is you're going to choose either the first point or the second point. In that regards, any point will work. Get used to something. So use the first point. My first point, the y is 5.08 equals negative 0.23 times x, and my x is 2 plus b. Let's do some math. 5.08 equals 0.23 times 2 is negative 0.46 plus b. I need to leave the b by itself, so plus 0.46 plus 0.46. Here cancels. And now this is going to give me 8 and 6 is 14. I carry 1. 4 plus 1 is 5. And then this is 5. And this cross out. And this is b. So my y-intercept is 5.54. My slope is this. My y-intercept is this. Therefore, my answer is b. Alright guys, subscribe to the channel. Please like the video. This is very important. Alright, turn on notifications so you get the notification when I upload the next video. Will be in the next couple of days. Take care, review. I'll see you next one, guys. Take care. Bye-bye.